let's see what we're looking at this week. If we switch over here, looking at our grade screen as usual, we are done with Module 4. Last week was the Module 4 project. Instead of a test, we had a program to write. We are starting now on number systems today, 5.01 number systems. March 22nd. Now, we had a lot of programs in the last unit. We had this was a program, 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 and this was technically a program, but we just did it in class and turned it into class. So if you have all of those done and you scored well on all of those, you're in really good shape for the semester because we do not have a program this week. This is a program next week. And classes and methods is a superhero program we're going to write. We're going to make a superhero class, get to create your own superhero, make your own superhero story. But that's it. I think we just have 2 programs left. I don't think we do anything in May for this. April 19th will be our last program due. So if you've already got all of these done and there's only 2 left, you should be in really good shape. So if you're missing any of these or did really poorly or tried to let AI write it for you and got a bad grade because you didn't write it, you might want to go back and get those done soon, and you'll be set up for the semester. So that's the good thing. Let me remind you, you may or may not have noticed, yesterday I posted in our Google Classroom a helper for last week's program, 4.06, the Module 4 project. I posted a video yesterday where I went through it step by step and explained how you can write that code. So if you have not turned on 4.06, then that is available for you in Google Classroom. Of course, you can also come to class on Wednesday. I'll help people in Wednesday classes for any of these ones. Maybe you got one older than last week's that still needs to be turned in. Whatever the case, let's get those turned in. Come see me on Wednesday. There is no school on Friday this week. Spring break comes a day early, so I can't help anyone on Friday. Generally, we've had in person on Friday, and we've had 30, 40 students up here every Friday, which is great. I've been helping a lot of students write programs the last several Fridays. And so that is available normally, except for spring break this week. So we do not have that on Friday. Thursday is the last official day of school for students. So there will not be any help on Friday this week. So get it turned in before Friday early and get the stuff done the earlier your spring break starts. All right, let's get back to this. Okay, going back to the activity screen. I'm going to close Module 4 since we're done with that. And I'll open up the Module 5 folder. Okay, number systems is where we're at this week. See, we have an exam at the end of this one. There's not a program to write at the end of Module 5. It's actually a test. And it'll be over all this number systems and the programming that's required to do all this good stuff. So pay attention. Types of numbers. Like, how many teaspoons are in a mile? Anyone calculated that up? Give it a good guess. How tall are you in gallons? Okay, just wondering about that. You're 8 gallons tall. I'm not sure how. Well, this is not typically how you would measure distance or height. You could probably figure out a way to convert the numbers somehow. I got a board game for Christmas called How Many What? And in there, it'll have questions like, how many butterflies tall is a horse? How many soda cans tall is a Empire State Building or something? I mean, it's weird stuff like that. You got to kind of guess, and whoever gets guessed closest. Yeah. So you could probably figure out a way to convert the numbers. In programming, there's a few different types of numbers. Some used to represent symbols, some used in calculations, some used to represent colors or memory locations, because member colors are in different types of numbers. So we're going to be able to, after this lesson, describe how different number systems are used to represent data. Page 2. Our world runs on 2 things. language and mathematics. And there's a lot of different languages, but math works the same in every language. We use language to communicate, and we use math to, well, do pretty much everything else. Think about it. If you're an architect, you need words to describe what you're doing, but you got to have numbers to make it all work. If you're a musician, words come in handy for the lyrics, but numbers arrange your music and set the tempo. In programming, the type of number used depends on the type of data. Each number system has a different base, which is the different number of digits it uses. For example, the decimal number system. We use the decimal number system. It's base 10, and it uses 10 digits, 0 through 9. That's the 10 digit it uses. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 digits for a base 10 number system. So let's compare some number systems here and see how they're used. So like the decimal system. The decimal system is base 10. It's the most familiar number system to humans. Decimals are based on 10 digits from 0 to 9. For example, money uses the decimal system. All amounts use numbers based on a 10-digit system, like $1.50. The 5 is representing the zeros, the ones, the 5s is the 10s, the $1 is a decimal, so $1.50, base 10. The metric system is base 10 as well. The binary system, you may not use binary very often, but it's used a lot in computers. It's base 2. And yes, that means it uses 2 different digits. It uses the digits 0 and 1. That's the only digits used in binary. Binary numbers are what computer language is made of. So all computers use binary. Your phone uses binary. Your smartwatch is going to use binary. That's what computers process in. They're based on 2 digits, 0 and 1, and the combination of zeros and ones can be converted into other types of numbers or even words. Binary can represent words. Example, you can use the binary system numbers to write other types of numbers or words like 0011 001 0011 0010 0011 0011. That's the number 123 in decimal. In decimal, we would just write 1, 2, 3. In binary, you got to write those 24 zeros and ones in order to represent 123. Because it only uses 2 digits. Hexadecimal. Here's the hexadecimal system. You've probably seen some hexadecimal, even if you didn't really realize what it was. It's base 16. So yes, it uses 16 digits. Hexadecimal numbers are most common in the computer world. They're used in relation with colors and memory locations. Like sometimes you'll see this. This is a color. That color pink right there is hashtag EA185F. So the 16 digits used in hexadecimal are 0 through 9 plus A through F. A represents 10, B represents 11, all the way up to F represents 15. So all colors have a hexadecimal code, with the hashtag symbol followed by a string of numbers and letters. Like hashtag FFD700 is the hexadecimal color code for the color gold. So you can see that, like if you look at web pages, if we inspect this web page, you can start getting through there. And if you get to certain parts of this, let's see. Hashtag 333. That's an interesting color. Background color, hashtag FFF. It has F's, 15, 15, 15 in hexadecimal to represent the background color that they're using here. So a lot of times that's in all this base code that's hidden back here that you don't see on web pages, but there's a bunch of code that's actually making all this look like this on the screen. And it uses those hexadecimals for different colors. Page 3. Converting systems. Things aren't always hashtag 00000 and hashtag FFFFF. That's white and black. Things aren't always white and black. Or I like this. I've seen T-shirts like this or posters. There are 10 types of people in the world. 0, 1, those who understand binary. 10, those who don't. Well, that's not in decimal. That's in binary. This says there are 2 types of people in the world. 1, those who understand binary, and 2, those who don't. It's a binary joke. So it's a shirt. It's got binary. So it's kind of clever. Math nerds love that kind of thing. Now, the great thing about different number systems, and you can convert from one to another. Like we saw that 123 decimal is all those ones and zeros in binary. So if you have one type of data in decimal form and you need to use a system that reads only binary, like a computer, you can do that. In the decimal number system, each place value is a power of 10, right? The ones column is 10 to the power of 1. The tens column, the hundreds column is 10 to the power of 2, so on, so on. Same's true for binary. An easy way to convert is to use an online calculator. You can find online calculators to convert from any number system to any other number system. But there's a nifty way to do it on your own without a computer. Sans computers, how it says sans means without. So if you want to go from binary to decimal, let me blow this up a little bit. Here's how you can do this with just using your hand. You get a marker right on your fingers. So here's a quick and easy way to convert binary numbers. Hold up your non-writing hand. Starting on the farmost left side, you put 1, 2, 4, 8, and 16. That's the numbers you write on your fingertips. So these are the powers of 2 because this is how binary works. So think of each finger as a binary number. If I close my hand where I don't have any fingers pointing out, that's like 0, 0, 0, 0, 0. And in binary, that equals 0. But if you put a digit up, like the thumb that has the 1 written on it, that's 1. That's 0, 0, 0, 0, 1. And it equals 1. If I put up the 2 and the 1, that's 0, 0, 0, 1, 1. And that equals 3, because this one equals 2 and this one equals 1. You add those together. If you put your whole hand up, 16, 8, 4, 2, and 1, you add all those together, that's 31. And that's in binary is 1, 1, 1, 1, 1. Just think of these as ones that you're putting up. So 1, 1, 1, 1, 1 is 31 in binary. So can you figure out what these numbers are? Well, this is all of them. I was just talking about that. That's 31. And it's easy if you just close in the thumb, since you have numbers written on your fingers there, you can just add those together. 16 plus 8 is 24. Plus 4 is 28. Plus 2 is 30. So that's 30. It'd be 31 if we put the 1 out. But since you don't have a 1, you just subtract 1. It's 30. If you just put the peace sign up, right? That's a 2 and a 4. That's 6. That's like 1, 1, 0 or 0, 0, 1, 1, 0 is the same thing. You can do 3 and 1. So can you come up with the binary number for 12? How can you do that with just the fingers? Well, you don't need the 16. That would be down. You do need the 8 and the 4. So you put this one down, this one down. So it's the 8 and the 4 is 12. So it's 0, 1, 1, 0, 0. There it is. 0, 1, 1, 0, 0. Second and third fingers are up, but the rest are down. Binary number for 12. All right, let me make this smaller. All right, let's go to page. Where's the page? There it is, page 4. Going from binary to hexadecimal. That's actually pretty easy because base 2 and base 16 are related to each other. So the number system has a base of 16. It's hexadecimal. It uses 0 through 9 and A through F. It's ideal to represent binary numbers with fewer digits because each binary number is considered a bit, and 4 bits can be represented with one hexadecimal number. Look at the breakdown. If we had this binary number, 11000111, Well, if we break it into two different bits, this uses a bit of storage memory, and this does too. So in binary, this is the number 12 because this is a 1 and a 2, and those are both 0. This is the 4's digit and the 8's digit. So we have 1 4 and 1 8. So this is 12, 1 1 0 0. But 12 in hexadecimal is just C because 0 through 9, 10 is A, 11 is B, 12 is C. So we can either put 1 1 0 0 in binary or just a C in hexadecimal. Then looking at the right side, we've got 0 1 1 1, which we have the 1's digit, we have a 1. We have the 2's digit, so we have a 2. We have the 4's digit, so we have a 4. We do not have an 8, so we add the 1, the 2, and the 4, and this is the number 7. Well, in hexadecimal, that's also the number 7. So in binary, we have to write 1 1 0 0 0 1 1 1, but in hexadecimal, it's just C7 to represent the same number. C7 just takes 2 little digits of memory as opposed to all of this. So the good news is hexadecimal numbers are much shorter. See, it didn't take nearly as much to write that in hexadecimal. That can be a huge time saver. So look at the binary and hexadecimals for 15. Binary, 15 is 1111. In hexadecimal, it's just an F. Well, that's a lot quicker to type out numbers. But you have to understand what the number is. So here's comparing. Here's the decimals. Decimals in the first column. Binaries in the second column. Hexadecimals in the third column. The decimal 0 is the binary 0, 0, 0, 0 is the hexadecimal 0. They're all 0. 1, pretty much the same. And the binary gets a little complicated because you got, for 2, you've got something in the 2's column, but nothing in the 1's column. So it's 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. And we're just a 7. 1, 1, 1, 0, 1, 1, 1 is just 7. Now notice decimal and hexadecimal are the same numbers until you get to 10. 10 is 2 digits, but since hexadecimal is a base 16, we have digits to represent 10, 11, 12, 13, 14, and 15. We just use letters. So hexadecimal goes from 0 to F. Decimal goes from 0 to 9 and then starts repeating digits as it goes into double digits. And of course, binary just has zeros and ones. Okay, let's look at page 5. Let's figure out how Python comes into this and helps us. Now you understand the different number systems. You can probably tell they take a while to figure out in your head. Like if I give you, all right, here's the number 311. Write that in binary. Or write that in hexadecimal. Either way, you're going, oh gosh, let me think. I'm not sure. Well, Python can do this for you. If we say age equals 17, we've created a variable called age. We give it a value of 17. Then we create a variable called binary age. But Python has a command, bin. That means convert this to binary. So whatever we put in parentheses, it's going to convert that. But we put age in parentheses. And age, we already stored the number 17. So it will take the age 17 and convert it to a binary number. And then we can print that. Print binary age. Okay, let's do it like this. I'm going to open up the idle window. Put that code in there. Run it. And look, there it is. There is the binary of 17. Now notice we've got these extra 2 characters out front. We have a 0B. The reason we do that because if it just printed 1001, you might think, oh, that's 10,001. It does this to let you know, hey, by the way, this is a binary number. So it puts that at the beginning of the number. 0B. This is not a decimal number. This is a binary number. It's the number 10001. It is not 10,001. So that's how when you look at a number in Python, you know whether this is a decimal number or a different number system. 0B is a binary number. So let's look at this. There's also a command called hex. If we want to know the hexadecimal number, let's just change this. Instead of binary, let's call this hex. 1-1. That's 1-1 in hexadecimal. And it uses a 0x to tell us, oh, this is not a decimal number. This is not a binary number. This is a hexadecimal number, 1-1. This is not 11. This is not 3. In binary, that would be 3. This is not 3. This is not 11. This is the hexadecimal number 1-1, which is equal to 17. Because there's 1 in the ones and there's a 1 in the 16s column. That's not a tens column. Decimal, that'd be a tens column. It's a 16s column. So there's 116 and 1-1. So we add those together, that's a 17. All right, let's look at the Python guided activity. Number systems, define main. Assign a decimal number to D. Okay, so we take a variable, we name it D, and we assign the value 7. D equals 7. And we're going to print that and tell you that is the decimal. It'll print the string value. It'll print as a string the value 7. And we're going to use that binary. We're going to use the binary command. We're going to say convert D to a binary number. So this time we're going to save it as B because we're letting that represent binary. The binary of whatever D is. Well, D is 7. So the binary of what 7 is. And then we're going to print that. So if we hit run program, the decimal value is 7. The binary value is 111. Notice that 0B just tells us this is a binary number. That's not part of the number. It just tells that this is not 111. This is a binary number, 111. Okay, let's change the value of D. Let's do something bigger. Let's do that 311 I was talking about. 311. Convert that to a binary number. Done. It's 10011011. That is 311 in binary. You're thinking, that's not even a challenge. How about the number 95213648557? What is that? 9 billion. Woo! Look at all the binary digits required to print out 9,521,000,000, etc. Takes a lot of binary digits for that. But that's a big number. All right. Let's look at the second program they give us. Assign a decimal number to D, 7, just like we did. Convert it to a binary number, just like we did. Print the binary number. Then this code converts a binary number back to a decimal. D equals integer. So we want to make it back as an integer. We made it as a binary up here, but we want to go back to an integer. And we're saying, here's the number, and the number is base 2 because it's a binary number. If we tell it what base that this B is, we can convert it back to an integer. Let's try that. 111 was the binary number, and 7 is the decimal value. That's what we set it at up here. Let's make that a bigger number. 6,213. In binary, 11000010001001. But that is 6,213 because it automatically, after it converted it to binary, it converts it back, saying, hey, by the way, this is base 2. This is okay. So no problem using Python to convert between binary and decimal. Now let's convert to a hexadecimal. We're going to assign the number 156 to the variable D. We're going to print that, say, oh, by the way, here's the decimal number we're using. Then we're going to convert using this hex command. Here's a hex command. H equals hex of whatever that decimal number is. And then we're going to print that. We're going to print H right here. The hexadecimal value is H. And then we're going to convert it back. We're going to say, hey, we want it to be back to an integer. That H, it's a base 16 number. So convert that back to decimal. Decimal is 156. It's 9C in hexadecimal. That 0x just reminds us this is not a number. It's not a decimal number. It's not a binary number. It's a hexadecimal number. That's what that 0x reminds us. Hexadecimal. And the decimal value again is 156. We can change this number. 879,156. Let's see if that 9C shows up in there. It does not. It's D6A34. That's less digits than we took here for the hexadecimal number, but we had to add the little tag on the front there. But it's D6A34. So easily to convert. Slide 4. B equals 0B. So we're going to add that to our input. We're going to enter a binary number, and it's going to add that to it because you have to tell Python this is a binary number with that 0B. Your binary number is, and it's going to print it out. So we have a program that we're going to enter a binary number. It's going to show us what the number is. Remember, 0B tells Python it's a binary number. Then we're going to use Python to convert it to a decimal. So we may not even know what number we're typing. D equals, the decimal equals the integer of this binary number, and we tell it it's base 2. This is a base 2 number. Please convert it to a integer so we can read it and then print it out for me. So enter a binary number. Let's see. Well, we can enter one that we know. We know 5 ones is 31. And it says the binary number is 0B. Remember, 0B is just a tag. It's not part of the number. It says this is a binary number. The number 11111. The decimal is 31. Okay, Mr. Brown, but we knew that. We looked at that on the other page. You're right. Let's have some fun with this. 1011100010. Just put a bunch of ones and zeros until we're tired of typing ones and zeros. There. What number is that? Well, that would take us a little while to figure out, but Python says that's the number, let's see, 3,097,817,741. Takes a lot more digits to type that binary because it's just base 2 instead of base 10. But yeah, that's very quick and easy to convert that from a binary number to a decimal number using the integer command. All right, this last program, print table headings. Oh, they're going to do a number systems chart. Look, we're going to do the decimal, the binary, and the hexadecimal, just like we saw on the other page, but we're going to generate it with a program. Here's the body of the table. We're going to use a loop. For D, D is our counting number, and we're going to go from 0 to 16, which means 0 to 15, because 16 is the stop. Remember, a loop stops when it gets to this number. And said, okay, so B will be the binary of whatever number loop we're on. H will be the hexadecimal of whatever loop number we're on. So we're going to print the decimal of whatever loop we're on, then the binary, then the hexadecimal. Let's run it and see. Nice. Look at here. We've got the decimal 0, the binary 0, the hexadecimal 0. They're all the same. 1, 1, and 1 is all the same. So it's getting different when the decimal 2, because that's 1, 0 in binary. It's just a 2 in hexadecimal. Remember, the first 9 are the same in decimal and hexadecimal. Different in binary. But as we get down here, we see 15 is just F. And since we're doing this in Python, we can make this bigger. We can say instead of going to 16, go to 160. There we go. So if I want to know 58 is 111010 or 3A. It's 3A. 57 is 39. Yeah. It's like the comedian I saw last month who's real nerdy. He was talking about, he was 56, but he's 38 in hexadecimal. It's a hexadecimal joke. You don't see those very often. But yeah, see, when I'm 64, I'll be 40. That'll be nice. See that's a more fun way to say that. But this goes all the way up to 159 because we told the loop stop at 160, and that's 9F in hexadecimal. So there's a nice little program to give you all three: the decimal, the binary, and the hexadecimal. And you can make that loop as big as you want. Figure out what numbers. 2000. Oh, I mean, back that up. There we go, 2000. Now when I run it, it takes a while. I had to think a little bit, but we can keep going and get really big numbers. Oh, 1999 is just 7CF in hexadecimal. Pretty simple. All right. Page 6. Complete the reading in the lesson. Practice with Python. Complete the quiz. Our assignment this week. Number systems. 5 questions. The hexadecimal number system uses 16 digits, 0 to 9 and A through F. Is that true or false? Which of the following represents 15 as a hexadecimal number? What's the purpose of the binary function? What does that do? Read this code. What's it going to print? Read this code. What's it going to print? So just 5 questions this week. So if you're still behind on last week's program, this gives you a good week to get caught up as well before spring break. Get everything done. You don't have to work on spring break. Now, if you've already taken your spring break by not working in the past, you got all these missing assignments. Your spring break may have to include some school. But hate that. Once you get everything done by no later than Thursday this week, because there's no school Friday either. So you guys have a great week. We'll see you next time. I'll be here Wednesday if you need some help.